In 1950, physicist Enrico Fermi sat down to lunch with colleagues at Los Alamos National Laboratory. The conversation turned to UFOs and the possibility of extraterrestrial visitors. After some discussion, Fermi asked a simple question that has haunted scientists for over 70 years. Where is everybody? Here's why that question is terrifying. Our galaxy contains between 100 billion and 400 billion stars. The observable universe contains roughly 2 trillion galaxies. The universe is 13.8 billion years old. If intelligent life can evolve, it should have evolved billions of times. Some of those civilizations should be millions or billions of years more advanced than us. They should have colonized the galaxy by now. We should see evidence of them everywhere. But we don't. No signals, no probes, no megastructures, nothing. The silence is deafening. And scientists have proposed over 70 solutions to explain it. Today, I'm going to walk you through the most compelling explanations for why we appear to be alone. And I have to warn you, some of these answers are deeply unsettling. Before I explain the solutions, I need to show you the math behind the paradox. Because once you see the numbers, you'll understand why the silence of the cosmos is so strange. The probability that we're alone in the universe is vanishingly small, and yet here we are, listening to static. Let's do some rough calculations. There are approximately 200 billion stars in the Milky Way. Current estimates suggest at least 20% have Earth-like planets in their habitable zones. That's 40 billion potentially habitable worlds in our galaxy alone. The galaxy is about 13 billion years old. Earth is only 4.5 billion years old. That means there was plenty of time for intelligent life to evolve elsewhere before Earth even existed. If even one civilization developed interstellar travel and decided to colonize the galaxy, how long would it take? Let's be conservative. Assume they travel at just 1% the speed of light. No warp drives, no wormholes, just advanced but physically possible propulsion. At 1% light speed, crossing the entire galaxy takes about 10 million years. That sounds like a long time, but the galaxy is 13 billion years old. 10 million years is less than 0.1% of galactic history. Even if colonization is slow, even if it happens in waves with long pauses, the galaxy should have been colonized many times over by now. And we're not just talking about physical colonization. Any civilization with radio technology would leak electromagnetic signals into space. Any civilization building megastructures like Dyson spheres would be detectable through their infrared signatures. We've been actively searching for signals since 1960 with the SETI program. We've surveyed millions of stars. We've listened across multiple frequencies. We've found nothing confirmed. The Drake equation formalizes this reasoning. It estimates the number of communicating civilizations in the galaxy based on factors like star formation rate, fraction of stars with planets, probability of life evolving, and so on. Depending on the values you plug in, the equation predicts anywhere from 0 to millions of civilizations. But most reasonable estimates suggest there should be thousands to millions of civilizations in our galaxy right now. So, where are they? This is the Fermi Paradox, the contradiction between the high probability of extraterrestrial civilizations and the complete absence of evidence for them. Scientists have proposed dozens of solutions. I'm going to focus on the 7 most compelling. And I need to warn you, the last 3 are the ones that keep physicists awake at night because they suggest something might be very, very wrong. What I'm about to reveal includes the Great Filter Hypothesis, one of the most disturbing ideas in cosmology. If you want to understand why finding alien life might actually be bad news for humanity's future. Subscribe to Orbit Explained right now. This is the kind of content that changes how you see our place in the universe. Let's continue. The simplest solution: we're alone. Maybe the evolution of intelligent life is so improbable that it has only happened once, here on Earth. We know life requires very specific conditions: liquid water, the right chemistry, stable conditions over billions of years, protection from cosmic radiation, and even if simple life is common, the jump to complex multicellular life might be extraordinarily rare. It took over 3 billion years on Earth. The jump from complex life to intelligence might be rarer still. Dinosaurs dominated Earth for 165 million years without developing technology. Intelligence might be a fluke, a cosmic accident that occurred exactly once. This is called the rare Earth hypothesis. Earth might be unique, or nearly unique, in its combination of life-supporting features. Some scientists find this comforting. If we're alone, there's no threat from aliens and no competition for the galaxy. Others find it terrifying. If we're alone, there's no one to help us, no one to learn from, and the entire future of intelligence in the cosmos depends on one fragile civilization: us. Maybe intelligent civilizations are common, but interstellar travel is harder than we assume. The distances between stars are almost incomprehensibly vast. The nearest star, Proxima Centauri, is 4.24 light-years away. With current technology, reaching it would take over 70,000 years. Even with advanced propulsion, interstellar colonization might be impractical. The energy requirements are enormous. The engineering challenges are immense. The timescales might discourage any civilization from attempting it. Maybe civilizations tend to stay home. Maybe they expand virtually into simulated realities rather than physically into space. Maybe interstellar colonization is possible in theory, but nobody bothers in practice. This solution suggests the galaxy might be full of civilizations, each isolated on their home world or in their home system, unable or unwilling to make the journey outward. We wouldn't detect them because they don't produce the signals or structures we're looking for. What if alien life is so different from us that we can't identify it? We search for life based on our assumptions: carbon-based biology, water-dependent chemistry, electromagnetic communication. But life might take forms we haven't imagined. Machine intelligence that evolved from biological ancestors billions of years ago. Entities that exist in plasma clouds around stars. Civilizations that communicate through gravitational waves or neutrinos. We might be surrounded by evidence of alien intelligence and completely miss it because we don't know what to look for. This is sometimes called the fish in the ocean problem. A fish has no concept of land creatures. It might swim right past evidence of terrestrial life without recognizing it. We might be equally blind to alien signatures that don't match our expectations. Maybe they know we're here, and they're staying away. This is the zoo hypothesis. Advanced civilizations might have agreed to leave primitive species alone, watching us like animals in a nature preserve. Why would they do this? Perhaps non-interference allows civilizations to develop naturally. Perhaps they're waiting for us to reach a certain level before making contact. Perhaps revealing themselves would cause social collapse among primitive species. A related idea is the Planetarium Hypothesis. What if advanced civilizations have created a simulated environment around us, an illusion that the universe is empty? We would have no way to detect the deception. These hypotheses are unfalsifiable. We can't prove aliens aren't hiding. But unfalsifiable doesn't mean wrong. It just means we can't test it. Now we enter darker territory. The next three solutions suggest that something filters out civilizations before they can make their presence known. And the terrifying question is, has that filter already happened to us, or is it still ahead? The Great Filter is a concept proposed by economist Robin Hanson in 1996. Somewhere between dead matter and a galaxy-spanning civilization, there must be a barrier, something that almost all potential civilizations fail to pass, something that explains the cosmic silence. If the filter is behind us, humanity got lucky. Maybe the origin of life is almost impossible. Maybe the development of eukaryotic cells is the bottleneck. Maybe intelligence or technology is vanishingly rare. We passed whatever the hard step was, and most potential civilizations never make it past single-celled organisms. If this is true, we might be alone, or nearly alone. The silence would make sense, because almost nobody makes it to our level. This is actually the optimistic scenario. But what if the filter isn't behind us? What if it's ahead? What if civilizations commonly evolve to our level, but then destroy themselves? Nuclear weapons, biological warfare, artificial intelligence gone wrong, climate catastrophe, resource depletion, self-inflicted extinction. Maybe technological civilizations inevitably develop the means of their own destruction before they develop the wisdom to avoid using them. We've had nuclear weapons for less than 80 years. We've already come close to global nuclear war multiple times. Climate change threatens global stability. We're developing artificial intelligence without fully understanding the risks. Maybe every civilization faces these challenges, and maybe almost all of them fail. This would explain the silence. Civilizations rise, advance, and then destroy themselves before they can spread among the stars. If this is true, our future is grim. We're on a path that almost everyone fails to survive. This is why some scientists say finding alien life would be bad news. If we found bacteria on Mars, that would suggest life is common, which would mean the filter isn't the origin of life, which would mean the filter is probably ahead of us. The more common life is in the universe, the more likely the Great Filter is something civilizations face after they develop technology. Finding simple life would be evidence that we're doomed. The final solution is the most chilling. What if civilizations are silent because making noise is dangerous? This is the dark forest hypothesis, popularized by science fiction author Liu Cixin. Imagine civilizations in a dark forest at night. Each civilization is a hunter with a gun. They can't see the others. They don't know if others are friendly or hostile. The safest strategy? Stay quiet. If you reveal your position, someone might shoot you. In cosmic terms, any civilization that broadcasts its existence risks attracting the attention of a more advanced hostile civilization. Maybe the universe isn't empty. Maybe it's full of civilizations hiding in silence, afraid to make themselves known. And maybe the few who broadcast their existence get eliminated. If the dark forest hypothesis is true, our radio signals, leaking into space for over a century, might be a terrible mistake. Something might be listening. Now I want to hear from you. Which solution do you find most compelling? Option A, the Great Filter is behind us, we're rare. Option B, the Great Filter is ahead. Civilizations destroy themselves. Option C, the dark forest, everyone is hiding. Option D, something else entirely. Drop your answer in the comments and tell me, does the Fermi Paradox worry you? Despite these unsettling possibilities, there's reason for hope. SETI continues searching. New telescopes and detection methods are being developed. The James Webb Space Telescope can analyze exoplanet atmospheres for biosignatures. We might find evidence of life in our solar system. Europa, Enceladus, and Mars are all being investigated, and even if we're alone, that has profound meaning. It would make humanity infinitely precious, the only known consciousness in an otherwise dead universe. Every question we ask, every discovery we make, every moment of wonder and curiosity would be unique, the universe experiencing itself through the only eyes it has. Being alone would be lonely, but it would also be a tremendous responsibility. Here's what I want you to take from this video. The Fermi Paradox isn't just about aliens, it's about us. It's about what kind of civilization we want to be. Whether we'll be the ones who make it past the filter, or the ones who become another silent grave in the cosmic cemetery. The answer might depend on choices we make in the next few centuries. What happens next is up to us. Thank you for contemplating the cosmic silence with me. If this video made you think about humanity's place in the universe, subscribe to Orbit Explained. Every video is designed to take you to the edge of what we know. We've now covered 5 major topics: gravity, black holes, dark matter, dark energy, and the Fermi Paradox. The fundamentals of how the universe works and the biggest mysteries we face. But this is just the beginning. There are countless more questions to explore. How did the universe begin? What is time? Could there be multiple universes? Stick around. We're going to answer all of them. Until next time, keep looking up. I'll see you in the next one.